Hello everyone, welcome to AIT concept video. My name is Narala Siddhartha. My roll number is 20951A6744. My branch is computer science engineering with data science as specialization. So today my subject is image processing and analysis. So I'm going to discuss about the connectivity of pixels. So let's start. So I mainly divided the content into three parts. So in the first part, I'm going to discuss about what are pixels, and I'm going to give a basic idea about the pixels. The second part, I'm going to discuss about image processing and various image processing techniques that are used nowadays. The third part, I'm going to discuss about the connectivity of pixels, which is nothing but the neighborhoods and the relation between the neighbors of the pixels. So let's start. What are pixels? So, a pixel is represented by a dot or square on a computer monitor display screen. Pixels are public building blocks of a digital image or display and are created using geometric coordinates. Depending on the graphics card and display monitor, the quantity, size and color combinations of pixels varies and is measured in terms of display resolution. For example, a computer with a display resolution of 1280 into 768 will produce a maximum of 9,83,040 pixels on a display screen. So the pixel resolution spread also determines the quality of display. More pixels per inch of monitor screen yields better image results. For example, a 2.1 megapixels picture contains 2,073,600 pixels since it has a resolution of 1920 into 1080. The physical size of a pixel varies depending on the resolution of the display. So it will equal the size of the dot pitch if the display is set to its maximum resolution, and will be larger if the resolution is larger, since each pixel will use more dots. Because of that, individual pixels may become visible, leading to a blocky and chunky image defined as pixelated. Pixels are uniformly arranged in a two-dimensional grid, although some different sampling patterns are available. For example, in LCD screens, the three main colors are sampled at different locations of a staggered grid, while digital color cameras use a more regular grid. In computer monitors, pixels are square-shaped, meaning that their vertical and horizontal sampling pitches are equal. In other systems such as the anamorphic widescreen format of 601 digital video standard, the shape of a pixel is rectangular. So each pixel has a unique logical address, a size of 8 bytes or more, and in most high-end display devices, the ability to project millions of different colors. The color of each pixel is determined by the specific blending of the three main components of the RGB color spectrum. Depending on the color system, a different number of bytes can be allocated for specifying each color component of the pixel. For example, in 8-bit color systems, only 1 byte is allocated per pixel, limiting the palette to just 256 colors. In the most common 24-bit color systems used for nearly all PC monitors and smartphone displays, 3 bytes are allocated, one for each color of the RGB scale, leading to a total of 16,777,216 color variants. So a 30-bit deep color system allocates 10 bits each of red, green and blue for a total of 1.073 billion color variations. So however, since the human eye cannot discriminate more than 10 million colors, more color variants do not necessarily add more detail and may even lead to color banding issues. So, image processing. Before we jump into image processing, we need to first understand what exactly constitutes an image. An image is represented by its dimensions, height and width, based on the number of pixels. For example, if the dimensions of an image are 500 into 400 of width into height respectively, the total number of pixels in the image is 500 multiplied by 400, which is nothing but 2 lakh pixels. This pixel is a point on the image that takes on a specific shade, opacity or color. It is usually represented in one of the following. Grayscale. A pixel is an integer with a value between 0 to 255. 0 is completely black and 255 is completely white. In between these 0 to 255, all the colors exist and varies. So what is RGB actually? So here RGB actually stands for red, green and blue. A pixel is made up of 3 integers between 0 to 255. The integers represent the intensity of red, green and blue. So what is RGBA? It is an additional extension of RGB with an added alpha field which represents the opacity of the image. So it is nothing but RGB, but rather it has one additional feature which describes the opacity or the transparency of the image in fact. Okay, so image processing requires fixed sequences of operations that are performed at each pixel of an image. The image processor performs the first sequence of operations on the image pixel by pixel. Once this fully done, it will begin to perform the second operation and so on. The output value of these operations can be computed at any pixel of the image. So image processing is the process of transforming an image into a digital form and performing certain operations to get some useful information from it. The image processing system usually treats all images as 2D signals when applying certain predetermined signal processing methods. So there are 5 main types of image processing. They are visualization, find objects that are not visible in the image; recognition, distinguish or detect objects in the image; sharpening and restoration, create an enhanced image from the original image; pattern recognition, measures the various patterns around the objects in the image; retrieval, browse and search images from a large database of digital images that are similar to the original image. So let's discuss about the connectivity of pixels. An image is denoted by f of x comma y and p comma q are used to represent individual pixels of the image. So the connectivity of pixels can also be classified based on its neighbors. So neighbors of pixels. A pixel p at x comma y has 4 horizontal or vertical neighbors at x plus 1 comma y, x minus 1 comma y, x comma y plus 1 and x comma y minus 1. These are called the 4 neighbors of p, which is denoted by n4 of p. A pixel p at x comma y has 4 diagonal neighbors at x plus 1 comma y plus 1, x plus 1 comma y minus 1, x minus 1 comma y plus 1 and finally is x minus 1 comma y minus 1. These are called the diagonal neighbors of p, which is denoted by n suffix d of p. So the 4 neighbors are the diagonal neighbors of the p are together called as the 8 neighbors of p, which is denoted as n suffix 8 of p. Adjacency between pixels. Let V be the set of intensity values used to define adjacency. In a binary image, V is equals to 1. If we are referring to adjacency of pixels with value 1 in a grayscale image, the idea is same, but set V typically contains more elements. For example, in the adjacency of pixels with a range of possible intensity values from 0 to 255, set V contains could be a subset of these 256 values and can also be all containing. So we consider three types of adjacency. 4 adjacency, 2 pixels P and Q with values from V are 4 adjacent if Q is in the set N4 of P. 2 pixels P and Q, 8 adjacency. 2 pixels P and Q from V are adjacent if Q is in the set N8 of P. M adjacency, it is also called a mixed adjacency, which is a combination of 4 adjacency and 8 adjacency. So connectivity between the pixels. So thank you.